In this video, we present one more example of eliminating the parameter. So our equations on the board, x equals 3 minus 2 cosine t, y equals 7 plus 5 cosine t. So this tells us that x minus 3 over negative 2 is cosine t. But we also have y minus 7 over 5 equal to cosine t. So that tells us that y minus 7 over 5 equals x minus 3 over negative 2. So y minus 7 equals negative 5 halves times x minus 3. And so once again, we have the equation of a line, and a point on the line is 3, 7, and the slope of the line is negative 3 halves. We can once again sketch a graph of this. If we plot the point 3, 7, and then we try to, maybe we find an intercept, so whenever x is equal to 0, for example, then we're going to have a 15 halves plus 7, or 29 halves, 14 and a half roughly. And so we're expecting up here to have some kind of a y-intercept. Whenever whenever y is equal to 0, we have a little bit more work cut out for us, right? So we're expecting some kind of line like this. We could find the intercepts, not a problem. But once again, there's more to the story. Cosine t is between negative 1 and 1. And so x minus 3 over negative 2 must be between negative 1 and positive 1. If we solve this inequality, and remember, we're multiplying by a negative, so we have to switch the direction of our less than or equal to mean greater than or equal to. Then we add 3 to both sides. We're going to find out that x has to be between 1 and 5. So when x is equal to 1, we have negative 2 over negative 2, or a positive 1 for cosine. Whenever x is equal to 5, we'll have a 2 over a negative 2 and get a negative 1 for cosine. And so our x has to be restricted between 1 and 5. We're never going to see these actual intercepts attained. We could do the same kind of work to find the y values, or we could plug in to our equation right here our extreme x values and find the y values. Either way, so we can work out that y minus 7 over 5 is between positive and negative 1, and so y minus 7 is between positive and negative 5, and so that means that y is going to be between 2 and 12. And so somewhere over here we have the point 1, 12, and somewhere down here we have the point 5, 2, and we don't have any part of our line beyond that. And so although these parametric equations are describing points on a line, they do not describe the entire line. In fact, as t increases, the cosine is going to ensure that this function oscillates for x and oscillates for y as well. So as t goes from 0 to pi to 2 pi and so on off to infinity, we're going to see this line segment between these two endpoints being retraced over and over and over again. And you could picture that as a particle just bouncing back and forth between the point 112 and the point 52. So once again, we see how the parametric equations impose more structure than the underlying Cartesian relationship between x and y. I hope this has helped you understand the elimination of parameter and conversion of parametric to Cartesian when it's possible. You can probably guess that a lot of times we're unable to do the algebra to isolate the t and to achieve this. But this allows us to understand some of the curves that we get from parametric equations, even if they have extra structure.